Hello guys, welcome back to our channel. So today we are starting another video that is of electrostatics. Till now we have completed it oscillation. This is the MHT-CET formula marathon of 12th formula. Till now we have completed 11th, 12th max and 11th max as well. And 11th physics as well. So please go and watch that video. It will be very helpful for you to go and watch that video and you can learn very easily from that. It will help you during your exams. You can watch it on 2x during your exams. So till that time, please subscribe our channel, hit the bell icon and do comment. Let's begin with electrostatics. First of all, we'll begin with Gauss Law. What is Gauss Law? Phi is equals to cyclic integral E dot ds is equals to Q upon epsilon naught. This is very important. Phi is a total flux. Q is a total charge inside the closed surface. Now, electric intensity due to uniformly charged spherical shell or hollow sphere. So total charge on sphere is Q is equals to sigma into 4 pi r square. Total electric flux through Gaussian surface phi is equals to E 4 pi r square. Electric field intensity is equals to 1 by 4 pi. It is 1 by 4 pi epsilon naught into Q upon r square, and E is equals to electric field intensity sigma into r square divided by epsilon naught into r square. First, we will going to see it as case by case. So case 1, if point P lies on the surface of the charged sphere r is equals to r. So we get here sigma by epsilon naught, which is Q by 4 pi epsilon naught r square. If point P lies inside the sphere, sigma is equals to 0. Therefore, E is equivalent to 0. Now, electric field intensity due to long straight charged wire. So first, total electric flux on Gaussian cylindrical surface. So that is 2 pi RL into E. And second, E is equals to lambda upon 2 pi epsilon naught into R. This is with the formula. Electric field due to charge of infinite plane sheet. So first, charge per unit area. Sigma is equals to charge per unit area, or it can be Q is equals to sigma into A. Therefore, E is equals to sigma upon 2 times of epsilon naught. Now we have electric flux. So that is phi is equals to integration E dot ds is equals to E ds cos theta. So phi, this is also phi, is equals to Q upon epsilon. So phi is equals to Q upon epsilon naught into K. Now dielectric medium. Dielectric constant of a medium K is equals to epsilon upon epsilon naught. Electric intensity E is equivalent to 1 upon 4 pi K epsilon naught into Q R square. This is electric intensity. Electric intensity at a point outside a spherical conductor. So E medium Q upon 4 pi K epsilon naught into R square, which is equal to sigma into R square divided by K epsilon naught into R square. In this, R internal R is greater than external R. Second, E in vacuum, which is Q upon 4 pi epsilon naught R square is equal to sigma into R square divided by epsilon naught into R square, where R is greater than R. Sigma is equivalent to Q upon 4 pi R square. Now, third is E inside. E inside is equals to 0, where R is lesser than bigger R. Now, electric potential and potential energy. So, first, increase in potential energy. F dot dr is equals to du. F dot dr is equals to du. Now, second, du is equals to 1 by 4 pi epsilon naught q into q naught 1 upon R2 minus 1 upon R1. But change in potential energy is equivalent to work done. So WAB is equals to change in U is equals to 1 by 4 pi epsilon naught Q into Q naught 1 upon R2 minus 1 upon R1. This will be our formula. Electric potential energy. Third, by using R1 is equals to infinity and R2 is equals to R. Then we get U of R is equals to 1 by 4 pi epsilon naught multiplied by Q1, Q2 divided by R. Fourth, potential energy of two particle system. Potential energy of two particles. Two particles distance R from each other. So U of R is equals to 1 upon 4 pi epsilon naught into Q1, Q2 divided by R. And we put up values, we get here Q2 by 4 pi epsilon naught R into Q1 and vice versa. We can do Q1 also, we can make inside like Q1 upon 4 pi epsilon naught into R and Q2 outside. Now, electrostatic potential U is equals to electric potential V into charge Q. So, first over here, V is equals to U upon Q or V is equals to W upon Q naught, or it is W is equals to Q into VB minus VA. Electrostatic potential difference. V2 minus V1 is equals to U2 minus U1 Q is equals to dW upon Q. This is electrostatic potential difference between 2 points. This is between 2 points. Relation between electric field and electric potential. So let us know that E is equals to minus dV upon dx. Electric potential due to a point charge. So V is equals to W is equals to Q upon 4 pi epsilon naught into R. R is equals to infinity. A positively charged particle produces positive electric and negatively charged particle negative electrical. So R is equals to infinity. So we get here V is equals to Q by infinity, which is equivalent to 0. Electric potential due to and electric dipole. So here VC is equals to Q upon 4 pi epsilon naught into P dot R divided by R cube. So here in more vector form it will be like VC is equals to Q upon 4 pi epsilon naught into P bar R cap upon R square. Is A over here potential at an axial point. So it means theta is equals to 0 degree towards plus Q or 180 degree towards minus Q over here. So V at axial is equals to plus minus 1 upon 4 pi epsilon naught into P upon R square. B case if potential at an equatorial potential at an equatorial point. So theta is equals to 90 degree and V is equivalent to 0. Now, electrostatic potential due to system of charges. The potential V1 at P due to charge Q1 is. So V1 is equals to, that is the continuation case over here of electric dipole 1. So V1 is equals to 1 by 4 pi epsilon naught into Q1 upon R1 potential for a single charge. This is for a single charge over here. Now, for electrostatic potential energy of a two-point charges and of a dipole in an electrostatic field. So, potential energy of a system of two-point charges, U is equals to 1 by 4 pi epsilon naught into Q1, Q2 divided by R squared. Electric potential energy of a point charge. So, U is equals to 1 by 4 pi epsilon naught into K, Q into Q naught divided by R. Electrostatic potential energy for two-point charges and of a dipole in an electrostatic field. Potential energy for a system of n point charges. So it will be U is equals to 1 by 4 pi epsilon naught summation. All pairs we will consider n q j q k divided by r j k. Potential energy of a single charge in an external field. The potential energy because of QV R bar over here, R vector. Potential energy of a system of two charges in an external field. So that is Q1V R1 vector plus Q2V R2 vector plus Q1 Q2 4 pi epsilon naught R1 2. Electrostatic potential energy for two-point charges and for dipole of electrostatic field. Potential energy for a dipole in an external field. So we will get here W is equals to PE cos theta 0 minus cos theta. So here this work done is stored in the potential system. So U of theta minus U of theta naught is equals to PE cos theta naught minus cos theta. Now, if initially dipole is perpendicular to the field E bar, that is theta naught is equals to pi by 2. So we substituting it, so we get U of theta is equals to minus of P dot E, which is minus PE cos theta over here. If initial dipole moment, if we perpendicular E greater than theta naught is equals to 0, so we get here U of theta is equals to PE 1 minus cos theta. Now, reduction of electric field due to polarization of a dielectric. So, E bar is equals to E minus E naught. E minus E naught. So, polarization P is equals to X E into E bar over here. E vector, here it is not there. Capacity of a condenser C is equals to Q upon V. Capacitors in series, which is 1 upon C and 1 upon C1 plus 1 upon C2 and so on. If capacitors are equal, then 1 upon C equivalent is N upon C or C equivalent is C upon N. Capacitors in parallel CP is equal to C1, C2, C3. Effective capacitances and capacitors are equal, then C equivalent is equal to N into C. Now, types of capacitor. Parallel plate capacitor over here. First of all, parallel plate capacitor. First, so C is equals to K epsilon naught A divided by T. So here diagram will be like something this plus 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 and here it is minus minus minus. This is parallel plate capacitor. Spherical capacitor. So C is equals to 4 pi epsilon AB minus BA. So over here if there is a circular two plates, this radius is A and this radius is B. So this plus plus plus, this is spherical capacitor. Cylindrical capacitor C is equals to 2 pi K epsilon naught equal 2.30 log B by A. So this will be cylindrical. So one cylinder inside over here will make and one cylinder outside will be there. So that will be like something like this. Don't mind about the drawing. So sorry for that. So this is distance A and this distance is B, radius basically, and this is length L over here and near positive charges over here, and this is grounded basically. So this is cylindrical capacitor. Now parallel plate condenser. The intensity between plates E is equals to sigma upon epsilon naught. Therefore, E is equals to Q upon A K epsilon naught. Potential difference between two plates V is equals to E D. Capacity between plates C is equals to Kc naught. Parallel plate capacitor, parallel plate condenser, capacity of vacuum C naught is equals to A epsilon naught D. Capacitance of capacitive dielectric C naught E naught divided by D. Here the mentions are also given for you. Last time in the videos were not there, so this time I have added that as well. Types of the capacitance of capacitor on introduction of dielectric slab. So C is equals to A epsilon naught D minus T plus T by K. Dielectric fills up entire space, then T is equals to D. T is equals to D over here. So we get here K is equals to C upon C naught. By solving this, we get the capacitance of capacitor on introduction of dielectric slab. This is their arrangement and dielectric slab T thickness is an equivalent capacitance. A capacitance of a capacitor into the dielectric slab. If the arrangement consists of n capacitor in parallel plate areas A1, A2 and separate plate slab D. So this is the formula for that. The capacitance of capacitor on the introduction of dielectric slab is filled with conducting slab. K is equals to infinity. Then we get C is equals to D minus dt into C naught. The capacitance thus increases by factor of D divided by D minus T. Displacement current is equals to ID. Displacement current ID is equals to A epsilon naught. A epsilon naught over here. O naught dE by dt. This is there. Now, energy stored in a capacitor U is equal to half of Q square by C is equal to half of CV square, half of Q into V. Thank you. By this, we have completed this chapter. Please subscribe our channel, hit the bell icon and do comment. Thank you for watching.